Okay, guys, this is another example of the preliminary computation before we proceed with the development length problems. So in this problem, we are asked to determine the value of CB, ATR, and KTR if the following parameters are given. Okay, C1 is actually the clear cover at the sides. Okay, so for the 35 millimeter clear cover, so I'm referring to this value here. So this is 35 millimeter. So for C2, it's 40 millimeter. This is the clear covering at the top. For S2, this is 25 millimeter. The clear spacing between two layers. Okay, so eventually we have actually two layers of bars here. So let's call this the topmost layer, layer number 1, and the second layer, layer number 2. Okay, so you will notice that S1 is not given. In case this is not given, the value to use must be proportional to the symmetry of what the number of bars or how many bars are given at this layer 1. Okay, so eventually if this is the middle and it has to be in the middle, so the distance S1 is simply determined by symmetry. Okay, so if this is 300, you just divide this by 150. Okay, and then you subtract the distances here. So the side cover here and the side cover there are just the same, of course. So this is simply S1 is simply 300 over 2, the width of the beam, divided by 2, minus, okay, you subtract the clear cover C1, which is 35. Okay, and then the diameter of the stirrup, which is 10. And what remains is this value here, which is 1 whole of your dB. But still, this is referred to the center, which is at the center of your bar there. So we can add 1/2 of the bar diameter here. So let's have a closer look of this. So 1/2 of this bar diameter and 1 whole of this diameter becomes a 1.5 of the bar diameter. Okay, so this is minus 1.5 of the bar diameter. Okay, we can inject or plug in now the values of C1, which is 35. Okay, ds is 10 and the bar diameter is 20. Okay, so this has a total of 150 minus 65. So this becomes 185 millimeter. Okay, so that's the way how to do it. But if in case S1 is already given, you don't need to compute it. And there are a lot of ways on how to compute for your S1. Just remember that S1 is a clear spacing. Okay. Remember that this is a line of symmetry. Okay. In any case, if this is not symmetrical, in special cases, you have to compute it differently based on the given conditions. So we are now ready to solve for CB. Okay, what is the ACI requirement for your CB determination? So according to ACI, your CB is simply the smaller or the smallest of all the center to center spacing of your horizontal bars, and the center of the bar to the nearest surface cover. Okay, so we can take a look on the lecture. So for your a reference, you just go and look into this lecture. Okay, so this is the center of the bar to the nearest concrete surface, and 1/2 center to the center spacing of the bar. So we just look into our definition now based on the drawing. Okay, what's the smallest of the center to center? So we simply add C2. There's C2 there. This is the surface to the bar there. So this can actually be C2 plus ds plus 1/2 dB. Okay. Okay, so this is the one that I'm referring to now. This is your CB. This is the potential CB requirement that we are getting there. Okay. And another is this one here, the center here up to that surface. So it can be a C1 plus ds plus 1/2 of dB also. And also we have your S1 plus dB divided by 2. Okay, so we have 3 comparisons to make, or 3 values to compare among each other. So what is C2? C2 is given 40 plus 10 plus 10. Equals 60. We have C1 plus ds 35 plus 10 plus 10 is 55. And we have S1 is computed, which is 185 plus 20 divided by 2. Okay, so this is 205 is 102.5. Okay, so the smallest is, of course, eventually this one here. Okay, so your CB becomes 55 millimeters. So that's how to do it. Code applications are not difficult, but you have to understand them fully to implement them correctly. Okay, so we have, for the next is the value of your ATR. Okay, so this is the area of the transverse reinforcement. So the area of the transverse reinforcement is defined as those which are passing or crossing the potential plane of splitting. Okay, so if we would like to get your ATR, we have to understand the 3 schematic failure mechanism in terms of splitting. the corner splitting, the intermediate splitting, and the uh, horizontal splitting. Okay, so we have three. So for a corner splitting, your area is simply always twice the area of the stirrups. Okay. For intermediate splitting, or I'm sorry, it's actually equivalent to 1 times the area of the stirrup only. So you can simply remove that to that. And then for intermediate, also, this is the air equal to the area of the stirrup. So it is in the horizontal splitting failure that the area of the transverse reinforcement is actually changing. Okay, so if you have a horizontal splitting, your area of the stirrup is counted on the number of legs crossing the stirrup, or crossing, sorry, the splitting cracks. Okay, so let's draw now our potential plane of splitting here in our figure here. So I'll just use this figure to facilitate my explanation. So if my splitting is corner, so it means that you only have one location wherein the stirrup is crossed by the failure. Okay, also in the intermediate, okay, you have one particular point of crossing the area of a stirrup. Okay, that's why your area of transverse reinforcement is equal to the area of the stirrup. But when you consider now a potential plane of splitting which is horizontal like this one, okay, so the number of, or the area of the stirrup is equal to the, or the area of the transverse reinforcement is equal to the area of the stirrup which crosses this splitting failure. Okay, so this is now the splitting crack. Okay, and you had to add the legs. These are the two legs. If it's a three-legged stirrup, you have times 3. It's a four-legged stirrup, you have times 4. So eventually in our problem, in case there is a horizontal splitting, the formula for the area of transverse reinforcement is simply 2 times the area of the stirrup. But we have to check along the while which is the potential, which will happen. Okay, and how are you going to determine which will happen? It's a prediction, no? And you can predict it by simply looking at the values of C1, C2, S1, and S2. Okay, take a look at the length of this failure. So the length of this splitting failure on the corner is simply C1 plus C2. which is eventually 75 millimeter. Okay, so we simply take a look on that aspect. Okay, C1 plus C2, or let's write it corner, the corner splitting. Okay, C1 plus C2 equals 40 plus 35 is 75 millimeter. Okay, for the intermediate splitting, okay, so this is the intermediate splitting. Okay, so we simply use one crack, and this is what? Simply C's of 2, which is eventually in order for this to fall off, okay, it must have at least twice C's of 2. Okay, so this is 40 plus 40 is 80 millimeter. And for horizontal splitting, this is simply C1, okay, it's 2C1 plus 2S1, okay, which is 70 plus 185. Okay, I'm sorry, there's something wrong with this. This is only 85 millimeter. Okay, I'm sorry, this is 65. Okay, 85, I'm sorry. So 85 times 2 is 170 plus 70 is 240 millimeter. Okay, which is now the potential. So the lowest will prevail. So this is now your potential. And if you look at the corner splitting, the ATR there is the area of the stirrup, which is what? Pi over 4 d squared. Okay, so therefore, the area of transverse reinforcement is simply the area of the stirrup, which is pi over 4 times ds. Okay, so this is now square. Okay, so if I substitute 10 here, I think what will be my area is 78.5 millimeters square. Okay, and KTR, or our last requirement, will simply be computed by, I want you to use this formula so that you will not be confused. In SI, this is in SI, so this is ATR FYT all over 10 SN. Okay, so this is an SI unit. Substituting the value, so this is 78.5 times FYT is 300. I think it's 250 in the problem, so let's check it. Okay, so the problem it's 250 divided by 10 times S. The spacing is 200, and the number of bars to be developed is the 3-layer bar on top, which is 3. Okay, so computing this, we will arrive with a value 78.5 times 250 divided by 10 times 200 times 3. Okay, so this is 3.20271. Okay, and that is the last requirement that we ought to solve for this particular problem. Of course, your CB plus KTR over DB will be used finally on the computation for uh, length of development. Okay, so I hope you are enlightened with the computation of these variables. Thank you very much.